So I'm trying this a different way today. So we're going to see how all of my writing and stuff works out. So this is the second, like 2/3 of chapter 14. I'm going to go through, this is going to be a lot of practice problems. So if like you've got it after a couple, that's fine. You can try the homework, go ahead and try the group activity for 14 and some of the homework on Chem 101. And if you have questions, let me know. But like I said, I'm going to go through a bunch of practice problems specifically because you're going to see all kinds of different problems. And I feel like the only way to work through them is to see examples being done. So that's my goal today. Okay, so we are starting on 14.3. I've got problems involving equilibrium constants. So we've been talking about the equilibrium constant, what it is. We got products over reactants. We know it's to the power of whatever the coefficient is in the reaction. But how can we calculate what it is if I don't actually have every single specific concentration or things like that? So we know how to write them. We're going to do calculations with them today because we can actually find out a lot of things. So these two are pretty straightforward. So there's two types of problems involving KEQ that are really simple calculations, and you probably already could figure out how to do these. So example number 5 says, for the reaction below, what is Kc if at equilibrium I give you all of the concentrations? Okay, so we know how to write Kc on here. We know that Kc, Kc is products over reactants to their power. So it'd be CH4's concentration, which is 0.25, times water's concentration, which is 0.0060, all over, let's see, the concentration for carbon monoxide, which was 0.20, times the concentration of H2 cubed, because it had a coefficient of 3. So H2's concentration is 0.12. So that one would be cubed. That's cubed right there. Okay, so essentially you need to be careful when you're typing these into your calculator. Make sure the cubed is just on the 0.12 on the bottom. If you do this correctly, and I would check it right now if I were you, you should get 4.3. Sorry, I'm still getting used to this pen. You should get 4.3. Okay. All right, so that's pretty straightforward. Now we could also solve for an unknown concentration if I have the Kc and all the other values. So example number B, is for calculating an unknown concentration if I, for example, had Kc and all of the other concentrations. So if I'm just missing one. So again, very straightforward algebra. For the reaction of this, the value of Kc at 425 is 0.18. Remember, we don't actually need the temperatures unless we're changing the temperatures. It's just that K does change with temperature. So if I say the K value is at 425 degrees Celsius, then like we have to stay at 425 degrees Celsius. So you don't need that for your calculation. So if at equilibrium, the concentrations of H2 and I2 are both 2.50 times 10 to the negative second, then what is the concentration of HI at equilibrium? So this is what I'm going to do. I'm going to set up my K equation. Okay, anytime you've got an equilibrium problem, I'm going to erase these. You should probably just go ahead and set up your K equation anyway, because you're probably going to need it at some point. All right, so let's see. Here I've got my Kc would be equals product, so H2 and I2. Over my reactant, so HI, and that one would be squared because it's got a coefficient of 2. All right, so it says this is 2.5 times 10 to the negative, oh no, it says this is 0.18. So this equals 0.18, and I'm gonna plug in everything that I know. The one that I'm missing is just the one on bottom. So I know H2 and I2 are both 2.50 times 10 to the negative second. Now they're both the same. So instead of writing it twice, I'm just going to write squared over the HI concentration. Okay, so that's pretty straightforward algebra. We can solve for HI. And we are going to get 0.00347 molar if I keep my significant figures correct. All right, That's what you should get for that one. Now I have another example. If I were you, I would pause, try example number 7, and then check your answer with me.